So, good morning. Welcome to lecture 9 of Introduction to Programming. So, I think that in the last class and in between during the labs, people had questions regarding strings and arrays. And also, I think that multidimensional array was talked about during the lab. But I think that we'll talk about it again. So, in this lecture, we will not have any particular problem or structure, but we'll just study some aspects regarding strings, arrays, and multidimensional arrays. So I think that a lot of people have this confusion regarding arrays and string. So strings are they use character arrays for its internal storage, but that does not mean that all character arrays are strings. That distinction has to be understood well. So let's try that. Right, so let me now initialize this array character by character. Okay, so now this is a character array. Alright, so now these two things are there. So let's see, let's try to see the difference between these two. So what I'm going to do is, let's see that how many characters does it have. So there are 12 characters in this string, and now all the strings are null terminated in C. So that means that at the end there is this special character with the escape sequence, so which is \0. So this is called a null character. So its corresponding integer value as per the ASCII code is also 0. So implicitly this null character is there at the end, right? So this is 12. That means that now if I try to, so let me try to get some integer. Now you see that this is actually 13th character. Okay, so since the index is 12 and you know that the indices start from 0, so that means that this is 13th character, and it is perfectly alright if I access, because the length of this array is indeed 13. This should be actually, yeah, character pointer. This I cannot do that. So let me just try to do the similar thing for the another this character array, and let's see that what happens. In fact, let's -g just in case if we need to debug. So okay, so here both are 0 0. It just happens to be that actually this is 0 in this case as well, but I'm saying that it doesn't have to be. So I can in fact, let me try to write something, some non-zero value over here. And yes, so it's saying that stack smashing is detected. This is because I'm trying to write to something. So I'm trying to write to the index 12, and this, in fact, I should increase the font size. I'm sorry for not realizing this earlier. So you see that if I 97 over here, this is a problem. You saw that it said that there is something wrong, and what happened is that you tried to access a location which was beyond this size of the array, right? So size of the array is 12. That means that the valid indices for this one is 0 to 11, both inclusive. So if you try to write to something, this can go wrong, and this we demonstrated even in the last lecture. Now let me try to do something similar for the another one. So let me just I'll comment this out. But this is a valid location inside your program, because this last location is indeed is indeed null. It is occupied by null, right? So null character, this is how you specify if you want to write null to it. In fact, yeah, this has to be done before. That means that I'll do the declaration before. And now let's see that what gets printed. So what we expect to be printed is that for the first one it should print 97, and for the second one we are trying to access a location that is actually not there in the program, so the behavior is undefined, right? So we do this. Yeah, so again, I mean, this is expected because you are trying to access something that is not there. So let me just do this, right? So then in this case what it is going to print is it's going to print the ASCII character value of this exclamation mark, right? So ASCII value of exclamation mark would be some number as per the ASCII code. So I'm trying to write to a location which is still, it's there inside our program. And it should be perfectly fine to access it. So it's 0:33. So I think the 33 value is coming for this exclamation mark. It is over here, and you can see that basically this value is 0, which is a null character, this I don't know, maybe I am trying to do something illegal, that if it is a string and if I try to override on the null, it is not allowing me, because if I do this, then also, for example, let me just so that this should print 33, right? Because 33 is the ASCII code value for this exclamation mark. And if now I do this 97, then it is going to print 97, that means, which is ASCII code value for small a. So instead, if I try to print it as character, which is the first one, then it's going to print small a. I see what is happening. Okay, so I am not allowed. So this is so when I declare a string like this, this is hello world. So there are two different ways to, in fact, yeah, it's a good thing that this error has happened. So let me try to write it in another fashion, the same thing, and I should be able to do. $97. So let's print the third one as well. Now let's see what happens. So the thing is that if I declare a string over here, this string is essentially a constant, demarcated as constant inside your program. So if you try to modify a memory that is designated as a constant, it's going to create a problem. Happen over here, that is my guess. So let's try to check it out. So yeah, so now there is not a problem. So as you can see that the first character it printed as exclamation mark because we did %c. For the second one, it is the ASCII code of exclamation mark, which is 33, and for the third one, it is A. So since we wrote 97, which is ASCII code for small a over here. Okay, I am not allowed to write over here, because if you initialize a string like this, and we'll talk about pointers later. So this is a character pointer which is pointing to this space over here, but essentially this set of series of bytes where these characters are stored, that space is designated as constant and you are not allowed to modify it. So now if I remove this, again there should be a problem. So it should again tell me like some segmentation fault, this is expected. Right now, so now let me just remove, let me not do this thing. And this is fine. So now if I try to access the hello my string 12, which is the 13th index, and 13th index you will see that it will always be 0. So if I do this, then the value that will be printed will be exclamation mark 33, and I have to write %u, because otherwise the null character is something that you cannot see on the screen. Something like new line and space is also, I mean, they are white space character, you don't see them directly. So similarly a null character is something that you cannot see. So that is why I am printing it as %u. So right, so last character is 0, so 0 is the ASCII value for null character. Right, now let me do one thing, right? So you see that there is a space over here. Now instead of this space, what I am going to do is that I am going to specify a null character. And let me also do one more thing. I'll do one more null character over here. Okay, so now there are two null characters inside this, and this is indeed an array that is initialized, and I can modify it because the way I have declared, I said that I am not specifying the size of the array. Please take the size of the array that is large enough to accommodate this. So this is I think 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So this is also going to be 13. And now let me try to do one thing, right? So now print a string as the first one, and let this be hello. And please observe as to what will happen. So this is just a warning that we are saying it's a multi-character constant, etc. So I think that it would still behave the way that I expect it to be. So my guess is that it will just print hello, because after that we have inserted null character in between inside the character array. And when you give it to a printf, you say that I want to print a string. What it is going to do is that it will start from the pointer that is given to it, which is hello, and then it will keep on printing character until it encounters a null, and then it will stop. So that is my guess that that's what will happen, and that didn't happen. Okay. Oh, I see. Okay. Now I am hoping that, because there was a typing mistake. Yes, right. So what happened is that this is still a character array. You see that hello is still a character array, and this character array is containing two strings inside it. So let me put it this way, that all strings are character arrays, but not all character arrays are strings. And I think that this is an important difference that should be understood, right? So there are two strings. Now let me do another thing. So now what I'm going to do is that I'm going to give it a pointer of this place, which is how much that character is 1, 2, 3, 4, 4, 5, 6, and this is the 7th character. So if I add 6 to it, my guess is that it will print world. That is what I am guessing. Okay, and see, it printed world. So now you see that there are two strings inside the single character array. So strings are character arrays inside C which are null terminated, but not all character arrays are strings. So on a single character array I can have multiple strings, or I can have no string. So our original array, which was just this, so this is also a string, but if I do this, so now what's going to happen during printing is that it will try to print HELLO space and all of this, and then there will be another space, and it will try to go on until it hits the null character. And since what's going to happen is that you are trying to access a memory location which is beyond the size of the array, then the behavior is undefined, right? So some weird thing can happen. So let's try to print this as a string, this character array as a string. It is not a string, by the way, but I'm still saying that, let's print it as a string and see what happens. So I hope I saved it. Yes. You can see that there is a first space, there is a second space, and this is interesting, right? So now what happened? Hello world A has been printed, right? Now where did this second hello world A come from? So we have this array, right, where the last character, instead of the exclamation mark, we changed it to 97, which is the ASCII code of small a. So what happened is that after it printed this, it went on. Now when the memory was allotted for these two arrays, in this particular case they were back to back. So after finishing with this one, it started printing this one, and now this one indeed has this is null terminated. So if you specify it in double quote, the null character will be inserted implicitly, and this array is large enough because there are 12 characters and plus 1 for null. So it printed that, and then the last space is coming from here. So if you see that these are the two space in our original string, right? Then it started printing that hello my string, etc. And well, this is changed, and this last space is coming from the printf. We have a space inside a printf. But having said that, if I try to do it like this, as I said that the behavior is undefined, what's going to happen is that it will keep on going until it hits null. And because of that, the moment it crosses the boundary of the array, it goes beyond the legal bounds of the array, then the behavior is undefined. After that, you cannot say that what's going to happen. Right? So for example, I can, if I declare this earlier, then again the behavior might change. So let's see, does it change? So yeah, then it has a space, and then yeah, for some reason it might have encountered null. We did not specify null over there, but yeah, it just happened to encounter 0, which is interpreted as null character. So it printed that, and it came over here. So I hope that now this is very clear that all strings are character arrays, but not all character arrays are strings. Some character arrays are just character array, which is just a sequence of characters. I can pack multiple strings inside one character array, or it may not be even a string because there may not be any null inside it, which is this. So for example, what you see here in line 7 is just a character array. It is not a legal string, and if you try to print it as string, you don't know what is going to happen. Now this is a special case where this is indeed sequence of characters. It does it like that, but we haven't spoken about pointer and why this behavior is illegal. So what happens that this in here is designated as a constant. It's a constant sequence which you cannot modify, and this hello underscore str points to the first character of this thing. So you can read from here, but you cannot modify. So modification is not allowed. Okay, so that's the difference. So I hope that this difference is extremely clear between a string and a character array. Okay, so now let's move on to two-dimensional arrays. Now, so this is an array. So since I have this square bracket of unspecified size, then it has to take from the initialization. So this is an array of uninitialized size, and it is an array of character pointer. So you can say that it can actually potentially point to string. So the first element is going to point to S, the second one is going to point to basically the thing that starts from M, etc. But again, each of these individual locations are I cannot edit it. Right, so now what we want to do is that we want to print, and now we need to give the pointer to the initial character of the string, which is going to be just this, and so this should print all the days. So this should work out just fine. Some typo. Right, so it printed Sunday, Monday, Tuesday, Wednesday. This is fine, but now let me try to modify one of these guys, right? So if I do weekday 0, that means that it is pointing to something over here. So again, right, I'm trying to replicate the same mistake that I did in the previous program. I'm trying to write to something which is constant, and what is going to tell me that, hey, you cannot do that, right? And my guess is that if I try to do this, it is going to the behavior is undefined, right? It's going to crash or something. Yeah, I think the same typo is there. It is weekdays. And you see segment, right? So it is an array of all these constant strings. So these strings you cannot modify, but it is an array of, so weekdays is an array of this set of strings which are all constant. So you further cannot modify it. But if I can make it modifiable by allocating appropriate space for them. In fact, in this particular case, what's going to happen is that, let's say 1, 2, 3, 4, 5, 6. Right, so this is 6 character. That means the 7th character is going to be null. So let me try to access that. Let me just try to access the 7th character, and it's going to be 0. U2 is equal to weekdays 0, and 7th character is this. And let's say U2, you see that Tuesday is longer, so for Tuesday it's going to be 8th character, 1 2 3 4 5 6 7, and 8th character is going to be 0. And this is the 8th character. So this is all fine. I'm still trying to access the reading is fine. So reading any particular character, even if of a constant string, is fine. I'm not trying to modify it. And now if I try to print it, it's going to print 0 0, and then it will print these number of days, etc. Right. Okay, 077. I see. So what had happened is that in fact it printed M, which is because the first one, I'm read the 8th character of Sunday, 1 2 3 4 5 6, 7th character is 0, which is null, and then immediately it read M, and the ASCII code for M is 77, so that's what it printed. I wanted it to be for Tuesday, which is the 3rd element. So let me try to print this. Right, so it's 0 0. So try to understand that what it did, right? So this entire thing, it packed back to back, and all of this is constant. You are not allowed to change any of these elements. And this array is different than, let me declare another array which will also contain these strings, but then I'll be able to modify it. So now so now I'm hoping that I will be able to not only read, but I will be able to modify. So let me just modify 0 0. So the first character, I'll make it 65. So instead of Sunday, it should print capital A and A or something. That's what it should print. And my guess is that this should work, because now I am saying that this is a 2-dimensional array. It is array of arrays, and I don't want to specify how many bytes to reserve right now. You please take it from this initializer list. So the thing that is there in the braces that I have specified is called initializer list, and it says that why don't you just take appropriate number of elements for this thing. So my guess is that now this should be allowed. So please read this. It says that declaration of my weekdays as multidimensional arrays must have bounds for all dimension except the first one. See, because now there is a problem, right? So that all of these number of days have different lengths, right? And it needs to know that what is the length. So it says that you have to specify a constant integer, any integer expression which is available at compile time, and only the first one I can keep it empty. So I have specified 7 elements that it will automatically take. But for the others, I have to specify the bounds. So what is the longest word? I think the longest word is Saturday, probably 1 2 3 4 5 6 7 8 and 9. 9 for the null character. 9 and 10. Yeah, so I think that 10 is sufficient. Wednesday is 10. So anything more than 10 is fine. So I'll do this, and now it's going to come out as we were still trying to do something silly. Yeah, we were trying to do something silly because it should be this one. Yeah. Right. So as you can see that what just happened. It printed 127, and then U2 is not even specified, so it printed anything arbitrary. Okay, and here I am still printing weekdays. It should be my weekdays. Yeah, so then it's going to print the correct one. Yeah, so you can see that now this S is changed to A. Right, so when I allocated appropriate amount of storage, now this entire thing becomes modifiable. Now I'll be able to modify. In this one I can't modify. It's going to tell me that this is segmentation fault. Right, and this is a two-dimensional array, and as you can already see that if you want to make multiple dimensions, then all the dimensions, you know how large that dimension is, it has to be specified apart from the first one. Right, so first one, either you specify initializer list and it will take on its own, or otherwise it will just treat it as a pointer. I'm trying to do something funny over here, and I don't know how many people will be able to guess what's going to happen next, but bonus points if you do know what's going to happen. It compiled just fine. It didn't even give me any warning that I'm trying to do something illegal, and it just worked as expected. Right, so it still modified this thing, and what happened here. So I'm hoping that you are able to see the screen and are able to read things that is there on my screen. So as I said, right, the ultimate go-to guide is the standard, whenever you are in doubt for anything. I think this is fine. So what does it say? In the expression x square bracket I, which is equivalent to this. So you are adding x and I, and then you are dereferencing. If you don't understand what dereferencing is, that is fine. You don't have to worry about it. X is first converted to a pointer to the initial array of 5 integers. So it is talking with respect to this. Then I is adjusted according to the type of x, which is conceptually entails multiplying I by the size of the object to which the pointer points. So here the size of the object is basically the length is 5, so it is going to jump accordingly. Namely, an array of 5 integer objects, which is 5 cross 4 if int is 4 bytes, is going to jump by 20. The results are added and indirection is applied to yield an array of 5 ints. But if you pay close attention over here, this is an addition, right? So that means that if I do x plus I or I plus, it's going to mean the same thing. So one of the argument is going to be an integer, and another argument is going to be a pointer, which x. It is okay if you don't understand a pointer, and then it will know that okay, this is what I have to do when the pointers are involved in this addition, right? And this we'll see in detail when the pointer arithmetic comes. So that means that if I do I and then square bracket x, that is also a valid syntax, in which what it is going to do is it's still going to do this addition and then dereference. So this is completely legal, but it is a bad practice. But let's try, okay? Even I don't know at this point of time that whether this will be okay or not, because the token starts with 0, so I think that it might create a problem. But let's try, shall we? So no, it just worked fine. Right, so it still did what it is supposed to. Right, so for the first two argument when it does the addition. Okay, now let me talk about something about this multidimensional array. So imagine that you are doing, so in C programming language, essentially what you are saying is, see, first of all, I think that in the previous lecture I told you that it is a sequence of bytes, sequence of contiguous storage locations that is that is available, that is there. And so this 3 by 2 specifies actually 3 rows and 2 columns. So it will be like this, 2 columns and 3 rows. and this is visually appealing, but that is not how actually the storage is happen, right? The memory still have just sequence of addresses for you, so it is still, your memory is still linear. Suddenly some multi-dimensional thing does not happen in your memory. So what's going to happen is that your first element is A00, right? Now C is what they call a row major, basically row major allocation for arrays, and I'll explain what that is, as opposed to Fortran where it is column major. So I'll show you that how it is. So this is 0 1, and then the third one is so I'll just write the index, okay? Because so this is 0 0, this is 0 1, this is 0 2, there is no 0 2 because the size is only 2, so this is 1 0, and next is 1 1, and then next is 2 0, and next is 2 1, etc. So the sequence of storage locations that are there, so we are saying that, okay, reserve so much space for integers. So how many integers you are asking for? 3 multiplied by 2 is 6 integers. So the first storage location, so whatever is stored over here, that you can access by A00. Then immediately the next storage location you can access by A01. But then when you try to access the next location, it is going to be A10, and then A11, and then A20 and A21, etc. So now I think that it should be easy for you to understand that for any Aij, if you want to know that where exactly it is located with respect to A00, which is the first location. So if you want to compute the offset, see, because that is what internally internally the code has to find out that which memory location you are referring to for reading or writing, right? Which element you are referring to. As I said, that memory is still one dimensional, right? So from A00, how far is this coordinate? Aij. And since, as I said, it is row major, so first you finish the first row entirely, then the second row, then the third row, right? So that means that for any Aij, it is going to be what? It is going to be I minus 1 cross the dimension of your, basically the second dimension. So I'm talking about this location, so cross 2 plus j. Right, and in this we can verify that this is indeed the case, because if it is, let's say, A01, then actually I'll just, because then starts with 0, so it should not be I minus 1. Just hold on a second, where is the eraser? It says I multiplied by 2, so 0 1, so essentially this becomes 0, and then plus j, which is 1. So offset it, we are saying that it is in the next location as compared to 0 0 0, right? Because the difference is 1. Now if I ask that how far away is A11 from A00, right? So this is going to be what? This is going to be 1 cross 2, because 2 is the dimension, it is the second dimension, plus 1, which is 3, right? So it is 3 location away from A00, and let's see whether it is indeed the case. So this is the first one, so this is 1, 2 and 3, right? So for a two-dimensional array, this is the expression, and this calculation internally indeed happens. So either the compiler emits such a code, I think that the compiler emits a code which does this calculation of the offset with respect to that how far it is from this location. So when you try to read to any element aij, this multiplication and addition always happens. So it is always faster to access the first location, right? Because everything is 0 0, this multiplication, this is faster as compared to any other element, because other elements involve this multiplication and addition. And there are programs which are written for very extreme speed, which actually makes use of this fact. Obviously it breaks the abstraction of the programming language. What do I mean by breaking the abstraction? That means that a programmer should not rely on what the architecture is going to do. That is the compiler's job. It is the compiler's job to be aware about the underlying architecture and how internally things are done. But usually very good programmers actually, they know that if my program is going to run on this architecture and this is how it is implemented, they can do this thing. So the downside is that your program may not be portable. Upside is that if you know what you are doing, you can gain some advantage with respect to speed and size and various other things. So this is row measure. In the column measure, so imagine that you have a column measure allocation. So this is not done in C, but I think that you need to understand what's the difference. So that's why I'm writing. So again, let's say that you have something like this. So in this case 0 0 is the first element. Now the second element is not 0 comma 1, it is 1 comma 0 and then 2 comma 0 and then it comes 0 comma 1. So this is called a column measure allocation used in Fortran. And yeah, there are advantages and disadvantages on both sides depending upon what kind of calculation you want to do. Now what if I have, let's say, A3, 2 and 4. So this one, you can assume that you can think of it like a odometer. So if you have how the odometer goes on, so your first memory location is 0 0 0, the second memory location is 0 0 1, 0 0 2, 0 0 3, and now that's it, because 3 is the highest one you can have in this dimension, right? So this is, so then you go to the next one, so it is going to be 0 1 0 again, right? And then if so, essentially with respect to this, now if I want to access memory location A I J K, then how far will it be from the first element being 0 0 0? Going to be the expression. So the expression is going to be I multiplied by the full size, which is in this case it is 2 cross 4, which is 8, right? Then you have j multiplied by, this is the dimension, which is 4, and plus k. And I leave it to you as an exercise that if you have more dimensions, then how do you calculate the offset? So what it does internally is that the moment you are trying to access any element of an array, it calculates this offset and then directly goes to that memory location to either fetch the contents, that means reading, or it will store whatever you want to write. So when you do this thing as an array, it is called a random access container or random access storage. So any location you can get in almost the same amount of time. It doesn't matter where it is. It will just involve some multiplication addition, but that's it. right? And how many dimension can it have actually in so there is, in some sense it depends on your memory, that how much memory you have available. It's not restricted to certain number of dimensions. There are some limits are specified, that how large the name of your variable can be, so that is specified in the standard. So in this standard you can see that these limits are specified somewhere. With respect to those limits, essentially you can have multiple dimensions, 2 3 dimension, 4 5 6 7 8 9 10. But as you can see that the more dimension you have, the more complicated it becomes to access a particular location. So yeah, you should try to avoid it, but there are very natural applications, as in if you are working with matrices or tensors, etc., then it is very natural to represent your data, because visually it looks that yes, this is a 3-dimensional grid or 4-dimensional space, etc., you are working with. So it comes the application of multidimensional arrays come very naturally to those things. So thank you very much.